Hello, Chem 107 GCC students. This is Chapter 8 on drugs and pharmaceuticals. So a little history about drugs. We have been humans using drugs since 5000 BC. There is evidence that the Sumerians used opium back then. In 3500 BC, there are historical records of alcohol being used. There's descriptions on this on Egyptian papyrus. And then in 3000 BC, that's the approximate date that China started using tea and a plant called ephedra. And then in 2500 BC, this is the earliest evidence of eating poppy seeds among lake dwellers in Switzerland. Belladonna is an interesting drug. It's also known as deadly nightshade because it's a poison. It was used in ancient times to stop bronchial spasms for asthma and whooping cough. Now, Renaissance women in Italy used this juice for cosmetic purposes. It made your pupils larger, and they thought that was prettier. Don't try that one at home. There is a class assignment for Chapter 8. I would like you to research marijuana and its legalization in the 50 states of the United States. All you need to do is type up 25 facts that you find in your research with the sources listed at the bottom. Sources can be .gov and .edu sites and city sites. So maybe you look up a Colorado state site or a Denver state site. So you should be looking for what states have legalized marijuana, when, what has it done to their economy. Consider health, economic, scientific, environmental, and political aspects. Also, at the end, I want you to write an opinion about legalization of marijuana based on your research. This doesn't necessarily have to be your personal opinion, but it should reflect what you researched in your 25 facts. And then this will count as a quiz grade, one of our assignments. All right. First thing we're going to learn how to do is carbon line drawings. So often you see pictures like this in chemistry textbooks and journals. What's that hexagon mean with the 3 lines in the middle? Well, at every point, there's a carbon atom. Carbon is so important, the study of it is called organic chemistry. Organic chemists use line drawings to represent carbon and hydrogens in organic molecules. So we don't have to keep putting C, C, C and H, H, H. So we drew these little lines that represents the carbons and the hydrogens as a shortcut. About 12 million of the 27 million chemical compounds we know about are organic, which means they have carbon in them. In a carbon line drawing, each line is a bond and it ends with a carbon atom. A single line represents a single bond. A double line is a double bond. A triple line is a triple bond. Remember, a bond is 2 electrons. So a single bond is 2 electrons, a double bond is 4 electrons, and a triple bond is 6 electrons. So look at that little squiggle. It goes up, down, up. That's a molecule. Yeah, using our shorthand, that is a molecule. At the end and beginning of each line, there is a carbon atom. So there are 1, 2, 3, 4 carbon atoms in that squiggly line. So if you look below, you can see the molecule with the 4 carbons in the middle. Now, once you've put your carbons on the lines, at the end and beginning of every line, there's a carbon atom. Carbon atoms have how many bonds around them? Look at the picture. Look at each carbon. How many bonds are coming out of each carbon? You're correct if you said 4. Every carbon atom has 4 lines coming out of it. 4. How do we represent a single bond again? 1 line. There are no double bonds in that picture, are they? Because there's no double lines. How many electrons are in a single bond? 2, right? How many electrons are in a double bond? 4, right? Anyway, so in that drawing, we have 4 bonds around every carbon atom. So how many electrons are around each carbon atom? Yeah, 8. So 4 bonds times 2 electrons each is 8 electrons. So carbon atoms always have 4 bonds, which means 8 electrons. It's called the octet rule. We talked about that a little bit when we did Lewis dot structures. So the point is that squiggly line represents the molecule below it. Let's try another example. There's another squiggly line. 1, 2, 1, 2, 3, 4, 5, 6. That one has 6 carbon atoms in it. The beginning and end of every line is a carbon atom. Again, look at the drawing below. You can see 1, 2, 3, 4, 5, 6 carbon atoms in that drawing. How many bonds does every carbon have? 4, right? They have 4 bonds coming out of them. So how many electrons are around each carbon atom? 8, yeah, 8. So what you do is you put your carbons in place, then you fill up the remaining bonds with hydrogens. So you have to draw in the hydrogens yourself. So, like if we look at the very first carbon, it has 1 bond down to the next carbon. So we have to add 3 hydrogens to it. Then the second carbon has a bond in front of it to a carbon and a bond behind it to a carbon. So it needs 2 more bonds to 2 hydrogens to make 4. So you add hydrogens with single bonds until every carbon has 4 bonds. So that's kind of how we play this game. First of all, fill in your carbons, then add hydrogens to make 4 bonds to every carbon. Your turn. Here's a squiggly line. If you can, pause and fill in the carbons on the squiggly line, then add hydrogens so that every carbon has 4 bonds. All right, and here's the answer. That little peak is 2 lines, so we have a carbon, 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 3 carbons. Now add hydrogens so that every carbon has 4 bonds. And you get that drawing right there. CH3, CH2, CH3. Good job. Let's try some more. Now this is a double bond, single bond, double bond, squiggly line. Double, single, double. So put your carbons at the end and fill in hydrogens so that every carbon has 4 bonds. Okay, we got some double bonds in this one. All right, and so we fill in 4 carbons, carbon, 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 carbon. And then because the first carbon has a double bond, it only needs 2 more hydrogens to go to it. The interior carbons have a double and a single bond, making 3 bonds, so they only need 1 hydrogen bonded to the middle carbons to give them their 4 bonds. And then the last carbon, again, has a double bond, so it needs 2 more hydrogens to give it its 4 bonds. Again, carbon has to have 4 bonds. It can be 4 singles. It could be double, double. It could be double, single, single. It could be triple, single, just as long as it adds up to 4. Carbons have to have 4 bonds. 4 bonds means 8 electrons, the octet rule. This is also an organic molecule. I know it looks like a hexagon to you, but to me, it's an organic molecule. So, remember at every point, there's a carbon atom. So how many carbon atoms are in that hexagon? You're correct if you had 6. Now, coming out of each carbon atom, there should be how many hydrogens? 2, right? There should be 2 more hydrogens coming out of every point to give 4 bonds total. So again, in general, how many bonds are around a carbon? 4. How many electrons are around a carbon? 8. Yeah, carbon always has 4 bonds and 8 electrons around it. Carbon follows that octet rule. Again, 4 bonds can mean 4 single bonds, 2 single and 1 double, 1 single and 1 triple, or 2 double bonds. Here's one more I want you to try. This time I have a hexagon, but 3 lines inside it indicating a double bond. Go ahead and fill in the carbons and hydrogens. Hit pause. See what you can do with this. Hit pause. Fill in your carbons and hydrogens. And we're back. So that hexagon with 3 lines equals this. It's called benzene. You don't have to know that. But we have 6 carbons. Double bonds are alternating in this hexagon. And so each carbon only needs 1 hydrogen coming out from it. Notice every carbon in that picture has 4 bonds, which means 8 electrons. It follows the octet rule. And we're going to stop our first video there for Chapter 8. Bye, GCC. Catch you on the next one.